Today discussing about the thiophene. Thiophene is the five-member ring system. So as we discussed in the previous classes that pyrrole and furan. So these are also the five-member ring system, and these contain one heteroatom, which is the electronegative atom, and this thiophene contains the sulfur moiety as a heteroatom in the five-member ring system. So here the 4 carbon are the present, and then the 5 carbon is the replaced with the sulfur to form a heterocyclic compound, and this is the known as the thiophene. Thiophene is the tribal name, and the thio represents the sulfur. If you numbering the thiophene system, the numbering always start from the heteroatom like the previous pyrrole like furan, and after that it goes the ascending order, and it is the go to the 1, 2, 3, 4. Always we also nomenclature the thiophene by alpha and beta denoted like that. We can at a 2 position we can denote it alpha, and 3 position we can denote it beta. Respectively, in the opposition there is the from this side this is the 2 position, and it is also we can denote it as a alpha dot, and then 4 position we can denote it in the beta dot. These all are this numbering system are the same as applicable as the pyrrole as the furan. Pyrrole first isolated in the 1882 by the scientist Victor Mayer, and it was the various tribal name are the present in the case of the thiophene. When thiophene is the partially saturated, here you can see the 2 structure of the partially saturated thiophene, and one is the 2,3-dihydrothiophene. This is the name of the 2,3-dihydrothiophene because 2 and 3 position are the hydrogenated, and this becomes a partially saturated thiophene, and this is also a type of the partial saturated thiophene. Here this is the 2 and 5 position, so you can say that is the name of this compound is the 2,5-dihydrothiophene, and this is the 2,3-dihydrothiophene. When it becomes fully saturated and with the hydrogenation is the occur and all the pi bond, and it is the form of 1, 2, 3, 4 tetrahydrothiophene. And tetrahydrothiophene এটা আরেকটা ট্রাইবাল নেম আছে, এবং that is the used in the case of the that is the thiolene. Thiolene when it becomes the tetrahydro, when it becomes the tetrahydrothiophene or fully saturated, the compound name is the thiolene. This is the tribal name of the tetrahydro fully saturated thiolene. Thiolene when substituted with the 2 position, this is the known as the 2-thioenine. When it is substituted at the 3 position, this is the known as the 3-thioenine, and it is a heterocyclic compound showing the aromaticity character, and also showing the aromaticity character furan, also showing the aromaticity characteristics that are pi. These 3 are the pi excessive compound, because when we going to the resonance of this previous 2 structure, there is that every carbon atom containing some of the electronegativity, some of the negative charge containing. So that's why these are the pi excessive compound, and due to the showing the aromaticity, the thiophene are the resembles their chemical properties that resembles like the benzene. So resembles like the benzene, and you will see that these 2 tribal nomenclature of these 2 substituted thiophene. You can see at that 2 position when that is the substituted with the CH2, and this is the known as phenine. Phenyl, phenyl. So in the case of the benzene, we can say that is a C6H5CH2 is known as the benzyl. And when this is the substituted with C double bond O, that is known as the phenol. And in the case of the benzene, we can see that is the benzoyl group. So that is the similar to the benzene. Thiophene is the occurs in the coal tar as well as the shale oil. Coal tar means this is the present in the with the benzene. Benzene and thiophene একসাথে প্রেজেন্ট থাকার জন্য they normally আমরা যে নরমালি যে কোল টার থেকে যে পার্টিকুলার কোন কম্পাউন্ড পিওর ফর্মে যে আইসোলেট করা হয়, that is the normal fractional distillation এ করা হয়, and this fractional distillation the main mechanism that is the involving of the heat. But thiophene having the boiling point about 80 degrees Celsius and benzene is having the boiling point at the 84 degrees Celsius. These two are similar, so that it can't be isolated the thiophene that is the by the fractional distillation. Fractional distillation এ যেহেতু হিট অ্যাপ্লাই হয় সেজন্য থায়োফিনের যে isolation from the coal tar which is present in with the benzene, it is not possible to isolate from the benzene by the fractional integration. So সেক্ষেত্রে কিভাবে ফ্র্যাকশনাল সেভাবে কি ক্ষেত্রে আইসোলেট করা হয় বেনজিন থেকে, the important the basis of that is the sulfonation. Why? Because thiophene is the readily reactive to the sulfonated that the benzene, and as well as you can say that is the thiophene is the sulfonation readily occurs on benzene থেকে, because the reactivity of the thiophene is the greater than the benzene. If you order the reactivity order of the thiophene, a reactivity of the 5-member ring, there is the thiophene is the more reactive than the benzene, but it is the less reactive than the pyrrole and furane. So thiophene, due to the more reactive than the benzene, it is the easily sulfonated, and the sulfonation occurs with the treating with the H2SO4, cold H2SO4. The coal tar containing benzene is the treating with the cold H2SO4 and say, and for that there is the 2-sulfonyl thiophene is formed, which is easily wash out because it is the water soluble compound, and benzene is the insoluble compound, that is the water insoluble compound, and it is the organic solvent, and that's why it is the easily wash out, and after that desulfonation can proceed for the obtain the pure thiophene molecule. So in that cases the question is the so বেনজিন যে কোল টারে যে বেনজিনের সাথে থায়োফিন আছে কিনা সেটা আমরা কিভাবে করব, তাই সেটা আমরা কিভাবে টেস্ট করব যে থায়োফিন প্রেজেন্ট আছে কিনা। যদি প্রেজেন্ট থাকে সেক্ষেত্রে আমরা এই প্রসেসের থ্রু the sulfonation through we can separate out the thiophene. So in the presence of the thiophene in the benzene can be identified by the test that is known as the endophenin test, and in the endophenin test treatment of the 1 ml dilute solution of the thiophene in benzene means the solution where the benzene and thiophene are present, taken the 1 ml and which is react with the add on that solution we add the few milligrams of the isardi. So we can say that is the thiophene in benzene few mg of isardi is added in the solution of the 1 ml solution of the thiophene in benzene, and after that we added the slowly 1 ml concentrate sulfuric acid. So this is turns into the blue color, which confirm the presence of the thiophene in the benzene. If thiophene is absent, the blue color is not observed. So the blue color confirm the presence of the thiophene and benzene, and this test is known as the endophenin test. Now going to the physical properties, that is the of the thiophene, and thiophene, that is the content the sulfur atom, which is the electronegative atom containing the two lone pair as seen in the structure. So thiophene, so the conjugation, this lone pair is the take part in the system of the aromacity, and so that it is the so conjugation then like single bond double bond single bond double bond single bond double bond, because lone pair take part, and this is the that it is the content that each carbon atom of the thiophene, that is the content the sp2 hybridization and having the unhybridized p orbital, so that it form a pi molecular orbital that by the continuous overlapping, and that's why we can consider this thiophene is like that. When this lone pair is the taken part in the conjugation ring system, so we can like that, and this is the aromacity of the thiophene is the proven by the resonance, and the resonance occurs by the thiophene because thiophene is the less electronegative compound, and as we know that is the thiophene is when compared with the oxygen, nitrogen and sulfur. So thiophene is the less, the electronegativity order is the like that, and if you go the resonance of the thiophene, we can consider that is the thiophene containing two lone pair, and this lone pair becomes bond at that position, and this bond is the further move to upward, and here is the negative charge will be generated, and sulfur becomes positive. Further, this is the stabilized, because this is the unstable compound, it is stabilized by that formation of the bond, and after that here it is the generate a negative charge. Further, it also stabilized by the changing their electron, and it is the form bond at that position. This is the form at that 3 position a negative charge. And further, it is the form bond at that position. This is the further add-on, and this is the produced a negative charge. Here is the negative charge, it is the form bond, and this bond is the shifted to that one. So if you see that resonance of that, and it is, if you S is considered as the X, it is applicable for the both furan, it is applicable for the both in case of the that is the pyrrole. So in that case you can say that each carbon that is the having the negative charge, and that's why this is the having the more pi electron, because it is the contains total 6 pi electron to 4 from the unhybridized p orbital and 1 lone pair from the sulfur, which is the heteroatom, and that's why this is the contain the 6 pi electron and fulfills the Huckel's law for the aromacity. So if and this due to the 6 pi electron in the 5-member ring system, and that is the contain each atom, carbon atom alone, that is contain a negativity, and that's why this is this furan, this pyrrole and this thiophene, these three molecule 5-member ring system are the known as the pi excessive compound. So, we will focus on the resonance energy of the thiophene. So, it is the about 29 kilocalorie per mole. It is the highest resonance energy that compared to the pyrrole, in compared to the furan, and that's why it shows the higher electronegativity. Sorry, it shows the higher aromatic properties than the pyrrole and than the furan. So, thiophene is showing the higher aromatic properties than furan, than pyrrole. Than pyrrole, than furan. So it means the in the order of the aromaticity, thiophene is the higher aromatic properties, and after that pyrrole comes, and pyrrole having the higher aromatic properties than the furan, but less aromatic properties than the thiophene. And the lower aromatic properties among these three compounds, that is the furan, and this is the due to thiophene, why thiophene and contain the higher aromatic properties, because it's the electronegativity. As I say that the order of the electronegativity, the lower electronegativity heteroatom is the sulfur, because it's due to the less electronegative, it is not pull down the electron from the ring system. It is their lone pair is easily available in the ring system, and for that resonance is the occurs, and the delocalization of the electron is occurs, and that's why they show the higher aromatic properties among the other two, that heterocyclic compound furan and pyrrole. So this is the reason behind the aromacity of the thiophene. Now going to the another physical properties that is also important for have to know, that is the thiophene is the colorless liquid. It's having boiling point 80 degrees Celsius. As I showed that the benzenes having the boiling point 86 degrees Celsius. Sorry, 84 degrees Celsius. So this is similar to the thiophene boiling point. It is miscible with water. It is miscible with water, but it is soluble in the organic solvent like ether, like acetone, like petroleum ether, like and alcohol. And now going to the synthesis and chemical reaction of the, along with I have discussed the chemical reaction that like other aromatic atom, other heterocyclic atom, that is the 5-member thiophene furan, it is the susceptible for the electrophilic substitution reaction at the 2 position, because it is the easily form a 3 resonance intermediate, 3 intermediate which is the stabilized by the resonance, and if 2 position is the block, then it is the attacked at the 3 position. Blocks means it is the substituted, that is the 2 position is the substituted by other group. Then the ESR, electrophilic substitution reaction, occurs at the 3 position of the thiophene. Now going to the main part of the synthesis thiophene, that is the synthesis, and then on as well as that is the chemical reaction. About the synthesis of the thiophene, so thiophene is the maybe that is the synthesized in the various schemes, and the first one, the synthesized scheme, as I showed that the reaction 1, and that is the synthesis of the thiophene. So here we are taking that is the succinic acid, and this is the succinic acid. The sodium salt of the succinic acid is that taken COONA. So sodium salt of the succinic acid is that treated with the phosphorus trisulfide, and in the presence of the heat 180 degrees Celsius. This is the trival method, and this ring closure is the occurs, and it is the form thiophene. In the second method, that is from the unsaturated compound, and here we are taking the first, that is the methyl thioglycolate. This is the structure of the methyl thioglycolate containing sulfur atom, and this methyl thioglycolate is reacted with the dimethyl fumarate, and this is the dimethyl fumarate, and you can say that is the sulfur having the lone pair, and this lone pair is the attack at the double bond position of this compound dimethyl fumarate, and this double bond position is the open up, and it is the in this position is the attack, and that position for the ring closure, and this, and as well as this methoxy group is the liberated out from the compound. So further this reaction is the occurs and the presence of the base like sodium methoxide, the base, and at that case the ring closure is the occurs, and here that this is the form a double bond, and this is the substituted with the COOCH3 at the 2 and 3 position. At the 4 position, this is the double bond O occurs, and this is the thiophene, which is further treated with the hydroxylamine, because hydroxylamine the ketonic group is the convert for the nitrile group, NOH group, and NOH group further when reduced with the HCl, and it is the form of NH2 like that, and remaining the hydrogen in the form are bond at that position. This hydrogen is in the form the bond. So this is the form of thiophene, which is the substituted with the COOCH3 at 2 and 3 position, as well as the 4 position amine. So deamination is the carried out by the treated with the sodium nitrate HCl and hydrophosphoric acid, where the deamination occurs at the 4 position, and further it is the easily hydrolyzed to form the acidic. So 2,3-dicarboxylic acid, thiophene 2,3-dicarboxylic acid is the form. This is the synthesis of the substituted thiophene. And the third synthesis, that is known as the Palmer synthesis. This is also fluoride also is synthesized by this method. Here we are taking that 1,4-dicarbonylic acid, that is a 1, 2, 3, 4. So 1,4-dicarbonylic acid is that taken, and which is the heating of the 1,4-dicarbonyl compound with the phosphorus pentasulfide P2S5 at 95 degrees Celsius, and here is the rearrangement is the occurs at that position. This having the hydrogen, is also having the hydrogen. So this hydrogen form a bond, and here is this hydrogen form a bond in the next first one. There is a sulfur is the attack at the oxygen double bond oxygen position, and this oxygen is the open up. So the sulfur is the attack one carbonyl compound, and another carbonyl that another carbonyl group is the open to form the hydroxyl. So it is the form like that, double bond S. So here the present is the hydrogen, it is the form 1, and this double bond sulfur here attack at that position, oxygen is converted to the enol form, so that we found a molecule, and that is the containing the 2,3-dihydrothiophene, which is substituted with the hydroxyl group at the 2 position. And here the R and R dot always present at that position. This is the also a R dot is the present. Further here addition of the proton form a bond, and it is at last produced by removal of the addition of the proton. Here is the proton, it is the remove the water molecule, and remaining the hydrogen, it is the form a bond at that position. And so this is the and that is the form 2,5-disubstituted thiophene. This is the synthesis of the substituted thiophene from the Palmer synthesis. And this synthesis first, that is the condensation of the 1,4-dicarbonyl compound with the phosphorus pentasulfide in the presence of the heat, and there is the rearrangement is the occurred, followed by the reclosure method is the occurred, and to form finally yield the 2,5-disubstituted thiophene. The last one is the from acetylene. Thiophene is the manufactured by the cyclization of the N-butane from the with the sulfur. N-butane, that is the butane means that contain the 3 like CH2 and CH3. So this is the butane, 1, 2, 3, 4 carbon, and this butane is the treated with the sulfur at about 60 degrees Celsius, so that thiophene is the occurred with the elimination of the hydrogen sulfide, or we can passing the acetylene AC triple bond C, that is the structure of that is the acetylene structure, and 2 molecule of that acetylene is the passes with the hydrogen sulfide in the presence of the alumina to form the thiophene. Thiophene also obtained from the coal tar, as I said, that is the reflux with the benzene with aqueous mercuric acetate, where upon thiophene is mercurated, and also as I say in the first, that is the normally the first isolated, that is the from the sulfonation by the sulfonation, or it is also mercurated, and the mercuritic derivative is the occurs at the 2 position, and for that thiophene is the occur. This is the because of the due to the thiophene is the more readily reactive than the benzene. These all about chemical synthesis of the thiophene. Now going to the chemical reaction part. So now going to the thiophene chemical reaction, as I say, thiophene is the pi excessive compound, and as well as it is the reactive than the benzene, it is the highly more reactive than the benzene, but lower as well as the pyrrole and the fluoride. So this the electrophilic substitution is the occurs at the higher electron rich position, it is the C2 position, after that C5 position. If these 2 position are the block, this is the going to the C3 position. 2 position is the occurs, and as well as the occurs in the 5 position in case of the halogenation. Apart from the electrophilic substitution reaction, thiophene is the also behave with the reduction is also reduction में देखा जाए बस हाइड्रोजन ऑक्सीडेशन संभव है. These are the reaction of the thiophene. Now going to the electrophilic substitution reaction, and it is the substituted at the 2 position with the halogen. When that is the treated chlorination occurs, it is the form that 2 chloro as well as the mixture of the 2,5 dichlorothiazide. So X may be that is the chlorine, that may be the bromine. In the case of the bromine, it is the react with the acetic acid in the at the minus 30 degrees Celsius, or iodine mercury oxide is the present. So these are all occurs at the 2 position, 2 bromo thiophene and 2 iodo at 2,5-diiodine mixture of the thiophene. Nitration, it is the thiophene easily nitrated with the acetic anhydride per acetyl nitrated, which is occurs at the 2 position, as well as the sulfonation is the occurs through pyridine complex. When the use the pyridine sulfur trioxide complex, that at the 2 position there is the sulfonation is the occurs. Chloromethylation is the occurs when it is the treated with formaldehyde and HCl. Chloromethylation, which is also occurs at the 2 position. This is the formylation. Formylation is the occurs when it is the treated with the dimethyl formaldehyde, dimethyl formamide, and this with the POCl3, phosphorus oxychloride, and thiophene is the form of 2-formyl thiophene. This is the also known as the Bell's-Mayer-Hague reaction. Fidelka acylation is the possible, and Fidelka acylation is the possible in the presence of the acyl chloride, and Dihad is the catalyst is the present, that is the stannous chloride as a catalyst, which is SnCl4, and which is also substituted at the 2 position COR1. Alkylation is the also important, and the alkylation is the occurs at the R2 position as well as at the 1 position is alkylation. So when it is the tertiary, when it is the treated with the butyl lithium C4H9 Li, and this is the form of 2 lithium thiophene, and these 2 lithium thiophene easily carboxylation to form the this is the COOH converted to the COOH to thiophene to carboxylic acid. And S alkylation occurs when it is treated with the tertiary or 3-degree oxygen compound like the R3O minus BF4 plus boron tetrafluoride complex with 3-degree oxygen compound, and this is the thiophene, is the S is the R substituted with R. So that is the S alkylation occurs. Reduction and oxidation, now comes the part to the reduction and oxidation, and this is thiophene also go for the Monish reaction, and this the Monish reaction undergo, that is the formaldehyde and secondary amine, it is the form CH2NO2 at that 2 position thiophene. For details the reaction of the Monish, you can follow up the pyrrole reaction as I described in details on that cases. And because Monish reaction also, in the case of the pyrrole, it is also susceptible for the Monish reaction, and the oxidation reduction, and due to the depends of the various reducing agent and various oxidizing agent, there are various type of the lot of the product is formed. এবং অক্সিডেশন রিডাকশন যেহেতু বিভিন্ন ধরনের রিডিউসিং এজেন্টের জন্য বিভিন্ন ধরনের প্রোডাক্ট তৈরি হয়, সেজন্য this reduction is the like that when you treated with the thiophene with the sodium in the liquid media, so this is the form partially saturated, and it is the form 2,3-dihydrothiophene as well as the 2,5-dihydrothiophene. When it is treated with the excessive palladium hydrogen, it is the hydrogenated and all pi electron, and it is the form the tetrahydrothiophene known as the thiolene. When it is treated with aniline, ring is open, and this nickel is the react with the sulfur to form nickel sulfide, and it is the form of butane moiety. So this is all about reduction. Reduction is the important as well as the oxidant, because there is a various type of the reduction and oxidation possible, depends on the reducing agent, depends on the oxidizing agent. In the oxidation cases, the thiophene is the when oxidation with the nitric oxide, it is the break down in the malic acid as well as the oxalic acid. So break down malic acid and oxalic acid when oxidized with the nitric acid, and when oxidized with the as the strong oxidizing acid, it is a form 1,1 di. It is a form 1,1 dioxide thiophene, and this all about the reduction and oxidation of the thiophene also important, and from this chapter. And we already discussed in that classes that thiophene, their physical chemical properties as well as their synthesis and their various type of the reaction. And this alkylation reaction is the nucleophilic type of the reaction, other than this that electrophilic substitution reaction. So the completed the thiophene, and thank you all of you. As I missed that the biological active compound which contain the thiophene ring. So vitamin biotin, this is the example of that. Vitamin biotin is essential for the growth factor of the number of the microorganisms for animals, and it was the first isolated from the egg yolk, but it is widely distributed, easily obtained from the milk concentrates. And this is the content of thiophene ring, as well as the imidazole ring, and this is the imidazole ring, which is the conjugated with the thiophene ring. At the 2 position, it is the substituted with the CH2 COOH. So this is the growth factor, as well as the some NSAID, that is the sucrophene, and antipsychotic drug olanzapine also contain the thiophene molecule. For details, see the study material of the medicinally active compound and containing the thiophene.